Good morning. So my name is Yvan Le Neindre. I'm a Powertrain Senior Development Director at Great Wall Motors. I've been working for this company since 2014.
We know this year we invited many international drivers to this Taklimakan Rally. So they want to know what's the biggest value for inviting these drivers to compete in this event.
Yeah, so from a hardcore R&D perspective, bringing these world-class drivers is like hiring the toughest torture tester for our production vehicles. These drivers, they have competed in top-tier global events for years. They know off-road conditions, they know driving habits from all over the world. When they drive vehicles whose core components are 100% identical to our mass-produced models, their expert eyes and international racing standards, they quickly pinpoint issues in chassis tuning, powertrain logic, other systems under extreme conditions, and then they can deliver precise real-world feedback. The Taklimakan Rally's unpredictable terrain is a natural proving ground, far more demanding than any lab. The vast amount of real-world extreme data we collect during the race feeds into our global R&D database, become parts of our engineering standards and quality benchmarks, accelerates new model development, and eventually, through calibration updates and OTA improvements, it enhances the durability and the calibration of our production vehicles. So in short, we turn the toughest racing challenges into everyday reliability for our customers.
So the international drivers will give us some feedbacks for the vehicles. So what we want to know what's the unique value of their feedback on our overseas vehicle model development, such as the vehicle model for the high temperature Middle East or the long distance cross country in Australia.
So first, these drivers, they share similar driving habits with overseas users. So their feedback is more real world. They have competed in desert rallies worldwide, and they know the extreme heat of the Middle East or the long cross-country traveling in Australia and all type of rugged off-road terrain. Their driving sensations and operating condition judgments align closely with how overseas customers actually drive off-road and on long trips, so making their input highly relevant to end user needs. Second, they help us precisely identify the technical weaknesses in specific overseas scenarios, making our vehicles more durable. The Taklimakan's high temperature, long distance, and high loads mirror extreme environments in the Middle East and Australia. The targeted issue they raise enable us to improve heat resistance, durability, and long-range capability for overseas market models, ensuring our cars can truly handle the desert of the Middle East or the Australian outback. Third, their international race tuning expertise makes vehicle handling feel right for local preferences. Based on proven Dakar Rally tuning experience, these drivers offer professional advice on steering feel, power delivery logic, braking adaptation, and off-road mode calibration, helping us move beyond a home market mindset and better match the driving styles of overseas users.
We are curious about how we adapt our powertrain technology to global markets.
Yeah, so the core logic is precise adaptation, just like the driver feedback we discussed earlier. We know that energy structures, infrastructures, and driving habits, they vary greatly across the regions. So no single powertrain can meet every market's needs. So that's why in January this year, Great Wall Motors launched the Great Wall Motors ONE Platform. Think of it as a movable type printing for the auto industry. It fully covers 5 major powertrain types: ICE, HCV, PHEV, BEV, and fuel cell EV. Truly one platform, multiple powertrain, precisely matching the needs of different markets, users, and vehicle classes. So take the Great Wall Motors ONE S platform. Its part commonality reaches 95%. That not only shortens the development cycles and lets us respond quickly to global market changes, but also means lower repair costs and easier service for the users, delivering real technology for everyone.
We just talk about Great Wall ONE Platform. We know the energy structure of each department is different. For example, Brazil promotes ethanol. Middle East prefers gasoline. But Europe strongly pushes new energy. So we want to know how Great Wall Motor handles this difference.
Yeah, so Great Wall Motors follows a local for local strategy. Let me give you a few examples. So in the Middle East, to cope with extreme heat and desert conditions, we have reinforced the powertrain cooling systems with larger radiators and high-efficiency fans, ensuring stable performance even under sustained high load. We also send prototype vehicles to Saudi Arabia and to the UAE and other countries, hiring experienced local drivers for on-road validation and calibration, precisely solving real-world high-temperature pain points. In Australia, we have tough and varied roads, lots of sharp turns and aggressive driving habits, which demands extensive local testing. We ran tests in multiple cities, gathered direct feedback from local users, and brought in a world-renowned chassis tuning team to run repeated calibration sessions across all kinds of local terrain, sand, gravel, shallow crossing, to better match real-world driving needs and habits, delivering the stability and toughness Australian driver wants. In Brazil, we tailor-made the world's first ethanol flex-fuel PHEV. It features an intelligent recognition system that automatically adapts to any ethanol blend ratio from 22% to 100% and adjusts the engine strategy in real time. Finally, in Thailand, with high heat and humidity year-round, plus difference in soap pH level in local car wash, led us to raise the anti-corrosion standards. We collected more than a dozen local car wash soap samples, analyzed their chemical composition, and we adjusted our coating formulation so that the sealing every possible rust pass.
So the desert and the Gobi conditions has a very high requirement for the powertrain's sustained output power and heat dissipation. We know this year we sent several Hi4-T vehicle models to this event. From a technical point of view, we want to know what's the unique advantages of our oil-electric hybrid architecture in handling this continuous hill climbing and such high-temperature driving scenarios.
So in the extreme environment of the Taklimakan, Hi4-T offers several key technical advantages. First, the mechanical four-wheel drive plus 3 differential locks means more reliable in extreme recovery situations. Hi4-T uses a mechanical four-wheel drive layout with front, center, and rear locking differentials. During the sense start and recovery from being stuck, the wheel speeds are perfectly synchronized, and the torque flows seamlessly and instantly between all 4 wheels, effectively preventing single wheel or axle slip or digging, greatly improving the recovery success rate. Second, parallel hybrid drive. We have strong responsive power for dune climbing. Both the engine and motor can work together. The electric motor delivers explosive torque almost instantly, kicking in within 30 milliseconds for stronger, quicker response. At the same time, the system relies primarily on the high-power engine, using the motor to peak shaving and valley filling. This places less demand on continuous electric-only outputs, avoiding motor overload or rapid battery depletion. Third, we have sustained stable power with no drop-off under high load. Thanks to the efficient combination of the high-power engine and 9HAT, plus energy recovery during downhill or braking, Hi4-T maintains a stable state of charge. Even during repeated dune climbing and high-load ball maneuvers, torque output stays way above 88.7 of peak, ensuring consistent power and giving drivers sustained, controllable confidence to push hard.
So the powertrains of the vehicles participating in the Taklimakan Rally is 100% the same as our mass production vehicle. We are curious about how we apply this data into our mass production vehicle.
Yeah, that's a great question. This gets to the core of why we race. So the track is the ultimate test lab for production vehicles. Labs and proving grounds, they can simulate many conditions. But the Taklimakan's combination of intense heat, continuous full load operation for over 10 hours, and constantly changing surface grip that can only be replicated on a real race course. For example, the high temperature power output data we gather on the Taklimakan directly helped optimize the thermal management calibration of the 3-liter turbo V6 engine in our production vehicles. The turbocharger on this engine can withstand 980 degrees without active power reductions, and much of the validation and calibration of that extreme limit was done on the track. Another example, during repeated dune climbing, the Hi4-T's parallel hybrid strategy, when the motor handles peak torque release and when the engine takes over as the main driver, those optimization parameters, they came from countless runs on the track. At Great Wall Motors R&D Center, we have a tradition. Engineers, they bring laptops to the track, they spot issues, they tweak parameters, and they test again the next day. this data comes from running, not from calculation development philosophy, is the true meaning of racing to advance R&D.
GWM, go with more.